this is sample problem 4, where we have, in this case, we have been solving problems that involve parallel series on its own. Like, for now, we are having a case where we're having both parallel and series connection in one circuit. It is very simple. Don't look the complexity of it. It's very simple. You just need to apply the concept of parallel and series, of course, in this case. And you need to know when and where to apply it. It's very, very important to take note of that. When and where to apply it. When you look at this circuit now, you're seeing that this is point A, this is point B, and this is point C. You can see that from point B to point C, it is assumed that it is in what? Parallel. From point A to point B, it is what? Series. But now, if you resolve this to an equivalent resistor, it's going to give you one, right? Okay, now let's do that. So the first step is what? Despite the steps you calculate the current drawn from the supply, which is the current, the total current in this circuit, we need to know, we need to calculate the equivalent resistor first of all. So now we're going to take section BC first. So we have solution and we have resistant 1 and resistant 2. So our given parameters, we are giving R1 as what? 5.6 ohm. 5.6 ohms. We are giving R2 as what? 6 ohms, and we're giving R3 as what? 4 ohms. Now we have to take this part, only this part. So inside this part we are having point B. So we're having this is point B. Then we're having a circuit like this, of course. A resistor like this, something like this. Don't mind my drawing, please. Something like this. Okay, so we have something like this. Here we know this is the 6 ohms and this is the 4 ohms, right? And we have this is C. So now, when we resolve this, of course, this is R2, this is R3. We're going to resolve this and find the equivalent resistor. The equivalent resistor is going to be R4. Take note, we need to resolve this to what? An equivalent what? Resistor. Of course, in the case where we have in parallel, the formula will be what? The RO equivalent or total, which is something as RO total, is equal to what? RO4, right? This is equal to what? 1 over what? RO2 plus what? 1 over what? RO3. So when we do that, we have 1 over RO4, which is the equivalent, is equal to what? 1 over 6 plus what? 1 over 4. So when you punch this, what will you have, please? But to do LCM here, so you multiply this by this, multiply this by this, we have 4, multiply this by this, multiply this by this, then multiply both of them. So we have 4, when you multiply 4, multiply by 1, you have 4 plus, when you multiply 6, multiply by 1, you have 6. Then you multiply two of them together, 4 times 6 times 4 is 24. So this will result to what? 10 over what? 24. So therefore, when we inverse it, we have RO4 over RO1 over 1 is equal to what? 24 over what? 10. Which is something as what? 2.4 ohms. So therefore, the equivalent resistor or resistance between these two from point B to point C. Now, when we resolve this is going to give us one resistor. So it's going to give us a straight line that has one resistor. This is going to be called RO4. The value is what? 2.4 ohms. So therefore, this is the equivalent resistor of this case. So now we need to bring, so now we're going to alter this our diagram because we have successfully derived this to what? Equivalent. So we're going to alter this, we're going to clean this out. We're going to clean this out. So we're just going to call this point B. We move it here. We are seeing only one resistor, right? RO4. So we are seeing only this resistor. This is called RO4, where the value is what? 2.4 ohms. This is what we are seeing now. So this is the better way to do it. Then now, since I've gotten the resistor, the equivalent resistor around this point, we need to calculate what? The equivalent resistor in series. We need to calculate the equivalent resistor in series. Of course, we say that in the case where you have parallel, you resolve it to 1. In the case where you have series, you resolve it to what? 1. So for us to calculate this, we're going to also draw a structure. So we are seeing point, let's call this point A. Let's call this point A. We are seeing, so this is the R1, which is 5.6 ohms. We are seeing point B, which is here. We are seeing a resistor which is 2.4 ohm. Then this is point C. So for us to resolve this, we said that the formula for the resistors in series is equal to what? The RO equivalent. Now this is going to be equivalent. You can express this as equivalent or total because this is the total resistance in the circuit. Why we did not express this in terms of equivalent? Because we cannot have two equivalents in a resistor. We express this as what? RO4 for this case. Take note. RO4 in this case. So now we have the total equivalent resistor, which is the same as ROC. You can express it as this now. Equals to what? RO1 plus what? RO4, knowing that this is RO4. So we have RO4. When you do that, you have 5.6 ohms plus what? 5.6 plus what? 2.4. This is going to give us what? 8 ohms. So therefore, the equivalent resistor in this circuit is what? 8 ohms. You can also break down. See, this thing we did now, you can express it as one resistor. If you want to express it, you express it as only one resistor here, which is what? 8 ohms. But for some case, we're not going to do that. So now we can look into the problem, which is question number A. Okay, now we're going to solve this question. The current drawn from the supply. The current drawn from the supply. The current drawn from the supply is the total current. We're going to use Ohm's law with relation to total voltage, total current, and total resistance. Knowing that we have calculated what? The total resistance. So the total current, which is the current from the source, is equal to, from Ohm's law, we see that Vt is equal to what? IT multiplied by what? ROC. Knowing that the equivalent resistor is what? 8 ohms. Knowing that the total voltage is what? 64. You understand? So we're going to make the current supply formula. We have that the total current is equal to what? This over what? ROC. So we have this as what? 64 over 8. This is going to give us what? 8 ohm. Sorry, 8. This is the value for current. So current is amperes. So this is 8A. Okay, now the other part of this is what? The current drawn from the 6 ohm resistor. This is a 6 ohm resistor. The current drawn from the 6 ohm resistor. 6 ohm resistor. 6 ohm resistor. So we have the current drawn from 6 ohm resistor. So the current drawn from the 6 ohm resistors can be calculated. Now take note. The current drawn from the 6 ohm resistors is this. We're looking for this current that flows through this resistor. Now take note. When it flows, we said that current in series are what? Equal, right? Now let me bring this structure, this diagram to the former diagram it was operating. So let me bring this down. So we are having resistance here, a resistor here. We are having a resistor here, right? So we're having a resistor here, right? So this was 4 ohms, this was 6 ohms. They say calculate the current flowing through what? The 6 ohm resistor. Now, when the current is flowing, it flows from here. We said that current flowing in a series connection are what? Equal. It will flow from here, it's going to come here, the current is still equal. From here, it's going to come to B, the current is still equal. The moment it reaches here, it splits. So therefore, there will be a current for what? I root 2, right? And there will be a current for what? Root 3. So the concept is easy. It flows from here to here, it flows here, it comes here, and it splits into what? Two currents. Because we say that the voltage in parallel is what? The same, while the current is what? Different. Each resistor has its own what? Current. It's very easy. Now what we'll do is we need to find what? Knowing that the voltage is what? Equal at this point. We'll calculate the voltage for this, subtract it from what? 64. Then we're going to have the voltage flowing through this part. R1 has a voltage. So we're going to call this what? Voltage what? V1, right? We are going to calculate this voltage V1. Okay, now, so for now, I'm going to wipe this off. I'm going to wipe this off. So, for us to be able to calculate the resistor, 6 ohms resistor, we said that for series connection, the voltage are what? Different. While the current are what? Equal. We will use the current to calculate. We will use the voltage to calculate what? The current. The concept is easy. We need to consider resistance 1. The voltage for resistance 1, which is V1, so voltage in resistance 1, which is V1, is equal to what? I total, which is what we say that the current is the same in what? Series, multiplied by what? R1. So when we do that, we have what? What do we get as the value of the current? 8 ohm, 8 amperes, right? So we have 8 multiplied by what? 5.6. So please point out, what do we have? So you have 8 multiplied by 5.6. You have 44.8 volts. Now this is the value of what? The voltage at resistance 1. Now how do we calculate the voltage flowing through BC? How do we calculate the voltage flowing through BC? The voltage can be calculated by flowing through BC by subtracting the voltage at V1 from the source voltage. So voltage, this one, take note that voltage at R1 is voltage at AB, which is AB. The voltage in BC is equal to what? The voltage in BC. So voltage in BC, which is voltage BC, is equal to the source voltage, total voltage, subtracted by what? Voltage in what? AB. Take note that this is known as voltage in AB. It is known as the voltage in 1. So when we do that, we have the voltage in BC is equal to what? 64, right? Yes. 64 minus what? 44.8. So we have 19.2 volts. Now, the 19.2 volts is the voltage around what? And we said that the parallel circuit is what? The voltage is what? Equal. The voltage is equal in what? The parallel circuit. And the current is what? Different. So since we know the voltage are equal in this, for us to calculate the current in the 6 ohms, we know that the resistance in the 6 ohms is what? Which is the R is what? 6 ohms. So therefore Vm for V2, which is for the 6 ohms, is equal to what? I2 multiplied by what? R2. Now we said that the voltage in this R2 and R1 is what? Equal. Because it's what? A parallel circuit. So therefore V2 is equal to V3, which is also equal to VBC. Is that understandable? Do you understand? Okay, now so now when we make I2 formula, which is the current flowing through the 6 ohms, you're going to have V2 is equal to what? R root 2. This is also known as VBC over R root 2. So this is equal to what? 19.2 divided by what? 6. So please give me your answer. 19.2 divided by 6. What is the value of what? This is. So we have 3.2 ampere. So take note, the current flowing through the 6 resistance, which is the current in the R root 2 resistance, is what? 3.2 ampere. So this is how we calculate the current flowing through the 6 ohm resistance. So now the next question is to calculate what? The power dissipated by the 5.6 ohms. 5.6 ohms. Now it is also the power flowing through what? AB. So this is to calculate the power flowing through AB from this point to this point. So we are going to wipe this out. Let's wipe this out. So the power dissipated by the 5.6 ohms, this is ohms please, 5.6 ohms resistor, the power is dissipated through the 5.6 ohms resistor. So now take note, we are going to draw the diagram finish. So we have we're looking at the power in the 5, more of like the power. So we have a diagram which is point A. So this is point A flowing through a resistor. We have 5.6 ohms, and this is R1. So this is point B. But to calculate what? The power. But notice that the current flowing through this point is what? The voltage flowing through this point, we calculated it as what? 44.8 volts, right? So that's the current flowing through AB. So the voltage, which is V1, is equal to what? 44.8 volts. Now, what is the value of the current? Yes, the value of the current, we say that for series connection, the current is what? Equal. So what do we get as our value for the current? What do we get as our value for the current? 8 amps. We just cleaned this here, right? 8 amps. So therefore, the current flowing through this is what? When you come of I1 is equal to what? 8 amps. This is the current flowing through this. So therefore, we know that power is expressed as what? I multiplied by what? V. In this case, the power distributed by the 5.6 ohms is the P1. So therefore, we're using I1 and V1. We know this as what? 8 multiplied by what? The voltage is what? 44.8. So therefore, the power dissipated from the 5.6 ohms is given by what? So we have 358.4 watts. So therefore, this is the power dissipated from the 5.6 ohms. So the concept is very easy. We play with parameters that we have already known. Thank you very much. See you guys.